This is the last lecture for Chapter 3, Lesson 2, and the last lecture before you have your test. And so we're still talking about the interaction of Earth systems, and the last one we're going to talk about has to do with the geosphere. You can see there's kind of some stuff going down here. This isn't, just a smooth surface, or there's something has acted on this, and it has to do with something we call the rock cycle. And this is actually a diagram of the rock cycle made by a sibling of one of our 6th grade students, and I saw it today and I thought, this is really good, this is exactly what we need, so I had a picture of it and put it in here. And if you look, it goes through all the various steps of the rock cycle that we'll be going through in our lecture today. So let's first start out by defining rock cycle. The rock cycle is the series of processes that transport and continually change rocks into different forms. So here is kind of an expanded version of that chart there. You can see the different processes. We have our 3 main different types of rocks: igneous, metamorphic, sedimentary, and how each one can become the others and the processes that they go through in order to reach that point. And here is a diagram, kind of a side view of what it looks like in the landscape, and we'll kind of be referring to some of the different things that are happening here. During the rock cycle, they go through different phases, and sometimes they're not even rocks. Sometimes they are sediments like this, just bits of dust, not really anything we would refer to as a rock. And sometimes it's magma. And so definitely not a rock, but somewhere in the process of the rock cycle. Now, you can see here, when we have magma, we'll start out, there's no real starting point to the rock cycle, because just like the water cycle, it is a cycle, so it's continuous and things happen at any point in between them. So let's start out with magma. And magma, is molten rock and minerals underneath the ground. When it comes to the surface, we call it lava, but magma can actually start to cool and crystallize while it's still under the ground. And it goes through this process where, you see here, you have a body of magma under the ground, and what happens is, as it cools, you get crystallization of the magma, and it begins to settle, and then this entire chamber would begin to do that, and form these various types of crystals that begin to become igneous rock. Or it can go up to the surface and cool as lava. We see that's what we have here. And as it cools, as I mentioned, it crystallizes. And this is actually a close-up view of crystallization within an igneous rock. And the overall form of it is like this. You can see the various flecks of crystal in it. This is a piece of granite. And when the igneous rock forms under the surface of the Earth, it can go through a process called uplift. Uplift is the process that moves large bodies of Earth materials, including our igneous rocks, other types of rocks as well that form underneath the surface, such as metamorphic, but these large bodies of Earth materials to higher elevations. And so in nature, here's an example. There's different processes that we'll actually look at. One of them, but this process of uplift is associated with mountain ridges mostly. So earthquakes can heave, movements of tectonic plates, subduction, which we'll talk about momentarily, and intrusive rocks burst through the surface and form different types of mountain ridges or landforms and things like that. But once these rocks come through the surface, they are exposed to the other spheres. They're exposed to the atmosphere and the changes in it, like the weather and things like that. The hydrosphere, whether it's running water or rain, they're exposed to the biosphere. Some animals, including human beings, will have an effect on the geosphere. And so this process of the breaking down of rocks is called weathering. We see here this is caused by wind or water running through an area. It can also look like this. This is off of a coast. You can see that the water and wind weathered this area. And then I want to give you a definition of process, by the way, because we keep using that word, and I want you to understand the scientific definition when we talk about a process. A process is a natural phenomenon marked by gradual changes that lead toward a particular result. So if we look at our definition of uplift, it's the process, so this gradual change where large bodies of earth are moved to higher elevation. So it can happen sometimes quickly if it's something like an earthquake, but most of the time it's a slow, gradual change. And so this weathering, it doesn't happen overnight. The rocks are slowly broken down most of the time naturally through wind and water. But then there's a process called erosion, whereby the sediments from the broken down rocks are moved to another place. And you can see here the water washing away the sediments down into here. And then we have another process called deposition. And it sounds like deposit, looks like deposit. So the sediments you can see through the river are washed away by the river, and then they are deposited here on the shore. And more sediments are deposited. And so what happens then is we have a process called compaction and cementation. So we have this sedimentation where it's broken down through weathering and erosion. It's deposited here, and then as layers are continuously deposited on top of each other, they go through compaction. So they're smashed down together, and then as the pressure increases, they're cemented, cementation. They're cemented together, and that's where the sedimentary rocks are formed. Now, once those sedimentary rocks are formed, that's not the end of it, because sedimentary rocks can then form other types of rocks. So we have a process here. You see the through either the volcanic activity, you can have igneous rock, and then weathering and erosion and deposition, you can have sedimentary rock. And so you have it being deposited, and then it goes through a process called subduction. So subduction is where this lithosphere, meaning the top part of the mantle and then the crust, are actually going down underneath another part of the crust. And so it will take these sedimentary rocks or igneous rocks down underneath the surface again. And so there we can have metamorphic rocks formed. So there's pressure from the layers above, there's heat and pressure from the layers below, and that forms the metamorphic rocks. Then those, you can see here an example of metamorphic rocks having been formed, and then the sides being eroded away, and you can see the different layers as heat and pressure took its toll on it. So whether it's igneous still or sedimentary or metamorphic, it also has the possibility of either coming up again through uplift or melting and coming back into magma, and that's where we started our cycle. So the rock cycle, very much like any other cycle within the Earth's systems is continuous, and it happened before we came on the scene. Now we can add to that through excavation and things like that, but it was a process that we don't even need to mess with, and it will continue. So we will continue to see rocks breaking down and rocks being formed and the earth moving around, and the geosphere is a very active system, just like the biosphere or hydrosphere or atmosphere.